Hi folks, welcome back to another lesson, and we're going to move away from forces now and look at a wee topic called density. Now, unfortunately for us, there is a lot of practical work in here, which we're going to have to skip through. However, you may be able to try these if you have the items at home. So if you do, feel free to send me a wee photo and we'll put it on to the Govan Academy Science Twitter feed. Okay. So we're going to look at what density means and calculate it using mass and volume. We're going to then look at a method for measuring density and explain why objects float and sink according to their density. So first of all, to get you thinking about this, why do ships float? Because we all know they're made from metal, and metal is very heavy, and generally if you put a block of metal into water, it will sink to the bottom. So why does it float and why does it not sink into the water? So let's look at some definitions before we get to answer that question. So I'd like you to copy this in your jotter, and this is part of your notes. And density is defined as the mass per unit volume. So try and remember that one. And another way to say it is how much stuff there is in a given volume. So the equation for it is the given below. So again, if you copy this as well. Now, density is given by the symbol rho, so it's the Greek letter rho, and that's how you pronounce it. It has units of grams per centimeters cubed, or GCM to the minus 3. Now, you can use either units, they both mean the same thing. Just remember that if you use one, stick to it all the time. If you use this one, remember it's a small minus in front of the 3, and this one here, remember you must have that slash there for it to be correct. Now, to get density, you always do the mass, which is in grams in this case, so it's the odd situation where we don't have to convert it to kilograms, divided by the volume, which has to be in centimeters cubed. You can also have it in milliliters as well, because that's also another unit for density. So that means a third unit for density is grams per milliliters. Okay, or grams ml to the minus 1. So feel free to use any of those. You do have a lot of variety here, so just make sure you're familiar with all of them, but I would just pick one and stick to one all the time. Okay, so let's look at a worked example to see how do we calculate the density of an object. So we've got a 500-gram block of steel, has dimensions as shown below. So it's 6 centimeters by 4 centimeters by 2 centimeters. Calculate its density. Now, if you feel confident, have a go of it yourself. If you're not sure, I'll take you through the calculation in the next slide. So first of all, we know that our KFC technique, we have M is 500 grams, and we know its density, so therefore we need to find the volume. So we're not given the volume, but I would hope you remember from maths that the volume of any shape is just its length times its breadth times its height. So that's why I've done 6 times 4 times 2, which is 48 centimeters cubed. So make sure you're familiar with that volume calculation. Okay, so then we find the equation, rho is equal to m over v, and then we calculate it, plug in the numbers, and we get an answer of 10.4 grams per centimeters cubed. And remember, the units is really important. It is part of the answer there. Okay, so how do we measure the density by experiment? So feel free to try this at home if you've got a balance like a kitchen scale and you've got a ruler and you've got some object where you can measure the length, breadth and height of that object. So the technique is really simple. We weigh the object to find its mass in grams. We then measure its length, height and breadth and then calculate its volume. And then you use these to calculate the density. Remember, mass divided by volume. Now, if we were in class, I would have got you to do this for a range of objects such as this. Okay, now you probably won't have all of these at home, so don't worry about it. We'll maybe look at doing this when we get back into class because it's a really nice experiment to do. And essentially, we're going to use that to help us answer the next one. So could you copy this down, folks? Which is water has a density of 1 gram per centimeters cubed. An object will float if it has an average density less than this. So what that means is if you were to add all the masses together and then divided by all the volume. If the density is less than 1, then it will float. So if we think about the ship, what do we mean by the average density? Well, usually when we look at the ship, we're just thinking about the steel and the metal that's used to make that ship. However, that ship isn't made of just steel itself, it is also made of air, because you can imagine going into the bottom of that ship or going to the rooms of that ship, there's going to be air inside there. So if we add the mass of air along with the mass of the metal, then work out the density, that will give us an average density. And because that average density overall is less than 1, then that ship will actually float. So this is why objects which are made from materials which generally would sink can actually float. It's because you're going to take into account everything that object contains. If it contains air or something else, that adds to its overall density. Okay, so if you write this down again, folks, just this wee sentence here, okay, an object will sink if it has an average density greater than this, so 1 grams per centimeters cubed. And the idea then would be that we'd look at the densities of the objects you measured in class and see which one would float and see if this matches our theory. Okay, so feel free to try this one at home if you've got any plasticine. Blue tack would probably work quite as well. Can you measure the density of plasticine? Okay, if you're not sure, I'll show you how to do it. So the aim to measure the density of plasticine, the method, find the mass of the object using a balance. Okay, so you can do that fairly straightforwardly. Now, to find the volume is a wee bit trickier because the plasticine isn't a regular shape, so it's not like a rectangular box or anything like that. We've got to use another technique to find the volume. And the way we do that is quite clever. We take a measuring cylinder and we fill it with some water of a known amount. So, for example, this might actually read 100 milliliters. So let's just put this in here. Okay. We then put our plasticine in it, and then we'll know that this might be, for example, 150 milliliters. So what we've got to realise then is that the volume increased, and it increased by the amount of the plasticine that was put into it. So we now know that this is 150 minus 100, which gives us the volume of the plasticine as 50 milliliters. Okay, so that's one way we can find out the volume of any object that isn't a regular shape. And once we've got the volume, we've got the mass, we can just calculate the density. So that's a very neat trick to calculate density. And there's a really nice story about, I believe it was Archimedes, and how he used this idea to find out the mass of a gold crown. And we'll talk about that when we get back into class. Okay, so just to finish this lesson off, how could you make a submarine dive or rise to the surface? So we're obviously thinking about density here. So how could we make the density of the submarine bigger than 1? And how can we make it less than 1? So to do that, if you write this down, folks, so I put a wee cross around there. To make a submarine dive, water is taken in to increase its average density, making it sink. And then to make it rise, water is released to decrease its average density, making it rise. So there's a really nice mechanism there for using density in a practical application. And then finally, this is a challenge that I was wanting you to try at home. If you can get some plasticine or blue tack, try and see if you can make plasticine float. If you think you've got it, take a wee photo and email it to me, or you can put it on the Teams, and there'll be a wee prize for whoever can manage this challenge. So give it a go, folks.